Welcome back to our YouTube channel. Myself, I'm Srikanth Reddy. So today we are going to discuss the Codeforces Round 971, which is a D4 contest. So let's quickly start with the first question, guys, which is minimize. Now, we are given two integers a and b, and also given that a will always be lesser than or equal to b, and over all the positive integer values of c, and the value of c should range in between a to b. All we have to do is just find the maximum value of c minus a plus b minus c. Okay, so you'll be given the input format in this way. First line of input contains t, the number of test cases. Each test case contains two integers a and b, and the range for a and b is 1 to 10. Overall, we just have to print the minimum possible value of c minus a plus b minus c. Okay, we'll just observe few things here. All we have to do is just consider the minimum value of c minus a plus b minus c. We'll just consider it as some mathematical expression. Okay, first, what is this c minus a plus b minus c? This c and this c will be cancelled out, and the remaining is minus a plus b, which is b minus a. We want the minimum value, right? Which is b minus a. And in the question, it is given that a less than or equal to b. We can directly say that b minus a itself will be the answer. You just have to read the inputs. For each input, you just have to print b minus a. That's it. Stop the screen. I mean, stop the video, and you can code it up and come back again for the code explanation and the next question. Okay, we'll code it up. We'll just consider the first question. We'll go with Python. Now, in the first line, we have to read the number of test cases. So t equal to end of input, or in one line, you can directly read an integer t and loop over it. First in range of end of input. Now you have to read two integers a comma b, in a single line. So I can use a map function int comma input dot split. Okay. Now for every test case, all I have to print is just b minus a as discussed. We'll print the same. Print b minus a. That's it. Okay. We'll submit the code. That's it, guys. Yeah. We'll quickly move on to the next question. We'll start off with the second question. Mania, yeah, whatever, it doesn't matter. Yeah, you're playing your favorite rhythm game, some name, and the layout of your bitmap consists of n rows and 4 columns. Okay, because nodes at the bottom are closer, you'll process the bottom most row first and the topmost row last. Okay, each row will contain exactly one node represented as a hash. Okay. For each node, 1 to n in the order of processing, output the column in which the node appears. Okay, so it is very simple. You'll be given test cases. Yeah, that is okay. And after that, huh, yeah, if you see the input and output, this is anyways the test case. And after that, you'll be given 4 rows. will be given 4 rows and 4 columns. Out of this, you have a hash value. You have a hash value here, 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 here. You have them at the column indices 1, at 1, 2, 3, 4. The same way, if you observe it for the second test case, you have it at second column and also the second column. Okay, second column as well as the second column. So second and second. And similarly for the last test case, you have it at the fourth column. So all you have to do is, in the question he mentioned that because nodes at the bottom are closer, we will process the bottommost row first and the topmost row last. So what's a simple refinement to this logic that we can do? Let's say if we can store this in some array list or vector or some list, all we can do is just reverse them and print. That's it. And this is same as the expected output. That's it. Read something like a matrix and then just iterate through the matrix and keep track of the hash values that you are having. The moment you find a hash value in a column, in a row, you can just add it to an array list, and it is also guaranteed that you'll be having a single hash value in the entire row. It is also given. Okay, the code is very simple. Stop the video, code it up, and we'll discuss the code once you're done. Okay, so we'll start with the code. We'll select the second one and we'll go with Python. Now just consider the test cases for range of int of input. Now I have to read the value of n equal to int of input, and now I should consider some matrix for I in range of n. I should just insert a string and I read that string. Okay, there are multiple ways of reading. I am doing it in this way. Now consider some answer array list or array. Now what's the next step? Now we have to iterate through the matrix, and wherever we have a hash value, we keep track of the column index, and we'll store it to the array. We'll store it in the array. Okay. So simply for I in range of n, for j in range of length of array of 0, or you can even write 4 directly. It is because it is mentioned in the question that every column size will be just 4 in the matrix. That part is given in way, so you can even write 4. Anything is fine. So if my matrix of ij, if it is pointing to some hash character, what I'll do is simply I'll directly append the column index, which is j. Now what will I do? I'll reverse the array. Instead of reversing the array, what I'll simply do is, while length of array is greater than 0, I'll simply print array of last element and then remove the element. Instead of doing all that, what I'll do is array dot pop, comma, and equal to. That's it. And then for each and every test case, we have to print that in a new line. So we'll print this. But the thing here is, but the issue with this would be the indexing starts from 0. But if you saw the sample input and sample output, the sample output, he wants us to consider a one-based indexing, which we are not doing it. Just to just a simple code fix for that, we can just add +1 to this. That's it. Okay, we'll submit the code. Yeah, we're good to go. We'll submit. Running on test one, it says. Okay, runtime error. We'll see what's that issue. Hmm. Okay, it is matrix of 0, right? Not array of 0. My bad. Okay, we'll quickly fix this. Submit the code. Length of matrix of 0. Yeah, we'll submit now. This should work. Yeah, it worked. Yeah, that's it, guys. Okay, we'll move to the third question. The legend of Freya the frog. Freya the frog is traveling on a 2D coordinate plane. She is currently at 0, 0. Okay, we'll consider some Cartesian plane. She's at 0, 0, and it wants to go to point x, y. In one move, she'll choose an integer d such that the value will be ranging in between 0 to k, and jump d spot forward in the direction she is facing. Okay, initially she is in the positive x direction. After every move, she'll alternate between facing the positive x direction and the positive y direction. Okay, one move she'll move in the positive x direction, and after that she moves in the positive y direction. Okay, okay. So ultimately, we have to find the minimum number of moves she must perform to land on the point x comma y. Okay. Um. So the question says that we'll consider a simple coordinate axis or a Cartesian plane 0, 0. Okay. Let's say this is Cartesian plane. This is a Cartesian plane, and initially she is at the point 0, 0, and let's say this is some point x comma y. So the thing is, you'll also be given an additional integer d. Is it d or k? Yeah, you will be given k. You'll be given an integer k. All you have to do is just pick a random number from 0 to k. Random as in the optimal way. You should consider the value of d in such a way that 0 is less than or equal to d less than or equal to k. You should pick some value out of this k range in such a way that you should be able to reach this point x comma y in the minimum number of steps. Okay, so first she's at this position, and now let's say she considered some d steps in the positive x direction. Okay, in the positive x direction, let's say she moved this way, and after that she will now traverse in the positive y direction. So till here the coordinate is something like 0 comma d, and after that she'll move in the positive y direction. So once if you change this coordinate, okay, sorry, my bad, this will become yeah, it will be the same. Yeah, now this will become d comma d. In the same way, you should keep on simulating the same thing here, 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 and you should be able to reach the coordinate x comma y. That's the overall question. Think about the logic. The breakdown is very simple, just like the previous two questions. Even this question is more like a mathematical question. Okay, now the question here is, let's consider a single coordinate. Instead of considering both x and y coordinates, let's only go ahead with a single coordinate. Let's go ahead with x. Let's go ahead with x. Okay, you're at 0, and if you want to reach x by choosing d, obviously this is more like some greedy approach. This is more like some greedy approach. So what will you do? As long as there is a possibility, let's say this is 0 and this is 100, and if my k is 3, you'll keep on considering 3, 3, 3, 3, 3 as long as you reach 99, and after that you'll just pick the remaining thing. Okay, this point. So how can you reach from here to here? Can I simply say that it is nothing but x by d, I mean by k? Simply you can say x by k number of moves she is going to make. In fact, this is not just x by k. X by k will give us the integer value, but this is the case that I am discussing about. If you are at 0, if you want to reach 100, if you just write 100 by 3, if k is 3, it will give us 99. Sorry, 33. But in fact, you should also consider the remaining step which you're going to make one step forward. So I can say some seal value of this. But in fact, as you're starting from the positive x direction, this will be the number of moves for x. What about the number of moves for y? What about the number of moves for y? What about the number of moves for y? Just like that, similarly, seal of y by k. But additionally, there is something more that you have to deep dive in this. So what is that? Just think about it. Think about it. So if you see here, it is mentioned that you will be starting with the positive x direction and then to the positive y direction. In that case, this will be into 2, and again this will be into 2. Understood this point? And again, the first thing that you're going to start with is x. Okay, and the second x step that you're going to make is at the third step. Okay, you're starting in the first step, you're going to start with x, and in second step you are going to start with y, and third step you are going to start with x. But this is now pointing to 4, which is not what we are expecting, right? Instead, -1. It is because you'll have x moves on 1, 3, 5, 7, so on till x, that way. And this will remain the same. It is because y is at 2, another y step is at 4, 6, so on. That's it. Now the question is, what's the overall answer? So how do you get the overall answer? You have the number of you have the number of moves to reach x, and similarly for moves y. But how do you get the overall answer? If if x is maximum out of x comma y, then you can return moves x. So this is when if x greater than y, you can return, or equal to y even, you can return moves x. If x is less than y, then you have to return moves y. That's it. So overall, whichever is maximum out of this moves x and moves y, you'll simply return the value. That's it. Code it up, guys. We'll discuss the code now. Okay, we'll start with the code. First, the input format. For I in range of int of input, we'll read three integers which are x, y, and k. X comma y comma k equal to map of int comma input dot split. Okay. Now, as mentioned, we have to calculate moves x and moves y. So moves x is equal to ceil value of x by d or x by k. So math dot ceil. As we are using math function, we must import math, and now math dot ceil x by k into 2, and again minus 1, as discussed in the logic. And sorry, have written moves. Okay, so moves y equal to math dot ceil y by k into 2. So out of this, whichever is maximum, you'll return it. That's it. Moves x comma moves y. That's it. Okay. I guess everything is perfect. We're good to go. Yeah. Yeah. That's it, guys. Accept. And yeah, that's it, guys. Okay. Moving to the fourth question, Satyam and counting. So this question, I personally feel that it is more interesting, kind of geometry related, math and all. But yeah, it's a good question. We'll see the question. Satyam is given n distinct points on a 2D coordinate plane. It is guaranteed that the coordinate of y will definitely be either 0 or 1 for every points xi, yi. Okay. All you have to do is you need to count the number of different non-degenerate right angles. Okay, I'll explain what exactly these right angles and all that is. Um, we'll move forward for now. We'll be given the t number of test cases followed by n, where n represents the number of coordinates that you will be given, and at the end you just have to find the number of non-degenerate right angles. Okay. Um, what he's explaining in the question is what he's explaining in the question is you'll be given some n coordinates, okay, where y will either be 0 or will be 1. Okay, out of this out of this out of this you'll be given some coordinates of x, where the value of x can be from where are the constraints? Yeah, here it is. Xi less than n. And what's the value of n? N can be 2 into 10 power 5. So our xi value can go to 10 power 5. Our xi value can be can be will be in this range basically. Equal to n. Okay. But whereas our y will definitely be either 0 or 1. All you have to do is just count the number of right angle triangles. For example, for example, let's consider the example. This is a coordinate, okay? This is a coordinate and this is a coordinate, okay? And additionally, there is another condition that is mentioned where the value of n will definitely be at least 3. Okay, in that case, either there is a possibility to form a triangle or there is no possibility at all to form a triangle. So what is the condition where you cannot form a triangle at all? You cannot form a triangle when every coordinate lies on the same line. If it lies in the same line, you cannot form a triangle, obviously. Either two of it should be in the same line and another should be in the other line, or one should be in the same, other two should be in the other plane, so that you can form the triangle in this way or you can form the triangle in this way. That's a basic knowledge that you should have for this question. And now you'll be given all the coordinates, something like this. I'm just considering it randomly. Now let us consider these are the coordinates that you are having. How many triangles you can form with these points? One is you can form it in this way. Another is you can form it in this way, which is the second triangle. Another is third triangle that you can form it in this way. Okay, this is one part of the logic. Let's keep this aside. Let's keep this aside. So, how many such types of triangles you can form? How many such types of triangles you can form? You can form the triangle in this way. This is not the only way. 2 points in non-zero and 1 point in zero can form a triangle. We can get a triangle. And also you can consider this way. Again, 2 points on the y equal to 1 and one other point on y equal to 0. Okay, this is a more like a symmetric triangle, but still a valid triangle. Again, 2 points on y equal to 0 and 1 point on y equal to 1, which will form a right angle triangle again. So this is the right angle, this is the right angle, this is the right angle. And similarly, just like a symmetric right angle triangle, you'll again have something like this. And again, here we have the right angle. Now, we will come to a conclusion that these are the only four possibilities where you can form a triangle. But this is not the case. This is not the case. There are even more possibilities where you can form a triangle. How can you get that? How can you get that? The triangle looks something like this. So here, here, and here, where this is a right angle. Okay. And similarly, the inverted right angle for this will also come into the picture. So where do you have the right angle now? Here we have the right angle. Okay. Now, how do you validate this? How do you validate all these triangles and count all those? How do you count? Simply, let's say this is some x. This is some x. This is having some x coordinate. Okay. Now, what are you searching for? What are you searching for? This, if this is x in y equal to 1, in y equal to 1, if you have at least one x coordinate, you can consider this as a right angle triangle, you can also consider this as a right angle triangle, you can also consider this as a right angle triangle, etc, 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 which is the case that we discussed previously. Okay, now for now we'll continue. If this is the x and if this x is present, so what exactly we are keeping track of? We're just checking for for some coordinate x in the y equal to 0, for some coordinate x in y equal to 0. Okay, to keep track of all these things, what we'll try to do is we'll try to club. We'll try to club. Uh, if y is zeros, we'll consider some zeros and we'll keep on adding all the indices of x, of all x's. We'll store. And for all the coordinates of y's, we'll store it in some ones. And again here we'll store all x's. Now, again here x, x, again x, x. Now what about this? What about this? Here y equal to 0 and x is having some value. Now what are you searching for to get a right angle triangle? This value must be x minus 1 and this value must be x plus 1. Okay. And similarly, if there is some x minus 1, if there is some x plus 1, there must be some x. That's it. If you just handle all these cases, your code is done. Your code is done. So how will you convert this logic into the code perspective? How will you convert this logic to the code? Okay, just think how we can convert this logic to the code and simulate it. Okay, just pause the video, try to code it up and resume the video again. Okay. Okay, so overall, how do you handle this part? Simply, you have a case which I have mentioned previously. Let's say you have 4 points, something like this. Now, what's the answer for this? This is a triangle, this is another triangle, and this is another triangle where you have three such right angle triangles. Okay. Now, now, how do you use some mathematical induction to build a formula on top of this? It is simply the number of x that you have in y equal to 0 and number of x coordinates that you have on y equal to 1. You just need to sum up them with the number of zeros on y equal to 0. Let's say that is zeros. Simply length of zeros minus 1 plus length of ones minus 1 will simply be the answer. Okay, we'll just code it up. Okay, so this is the fourth one. Now, all I have to do is just read the input for underscore in range of int of input. Now, I have to read an integer n int of input. Now, I have to store them. I have to store all the x coordinates in some zeros array and in the ones array. So for that, I'll just initialize zeros and ones. Now, I have to read all those x and y coordinates. So I'll loop over n and I'll just write x comma y equal to map of int comma input dot split. Now, if our y is belonging to 0, then I'll simply say zeros dot append of x, else ones dot append of y. That's it. Now, additionally, sorry, again here x. Again, the point here is previously we were discussing that if if this is the coordinate x we have to search for x minus 1, we have to search for x plus 1 in the y equal to 1 array. But searching will take O of n time, which is what we know, right? Which is what we know. But searching in the array, how much time will it take? It will take O of n time. But as per the constraints, you'll be given you'll be given 10 power 5 coordinates, and t is again 10 power 4. Okay, so 10 power 4 into 10 power 5, and again searching will again take 10 power 5 time. This is not feasible. And overall, he mentioned that we have 2 into 10 power 5 at max. So okay, even if I consider that 2 into 10 power 5, if I do a linear search on the ones or zeros array, it will take n time, which is closer to 10 power 5, which will give us a TLE. So instead, we'll reduce the time for this by using a hashing. We'll store it in a hash map so that we can retrieve this in O of 1. Okay, so we'll parallelly store them in a hash map so that the solution will work. Okay, now I'll use some dictionary from collections, import default dictionary. Now I'll just say I have two dictionaries, default dictionary of type integer. Okay, I'll just copy this, I'll paste it, I'll use it here. Yeah. Now, the moment when I got this, I'll also add it to my hash map. Hash map of 1 of x plus equal to 1. And similarly, if if you want to store it in second hash map 2 of x plus equal to 1. Now we are done constructing the zeros array, ones array, hash map 1, hash map 2. All we have to do is just count the number of right angle triangles. Here goes the simulation part of our logic. Now, what exactly are we doing? We will just traverse through the y equal to 1s for x in 1s. Okay, for x coordinates in 1s. What are we doing here? For x coordinates in 1s, y equal to 1s. What are we doing? If we are at this x, we have to search for the number of x's on y equal to 0, and the coordinate should be the same. So simply, if my x is present in the first hash map, if that is the case, then what I can simply do, my answer plus equal to, this is what I was discussing previously, right? So simply my answer will be the length of zeros minus 1. Okay, plus length of ones minus 1. Okay, this part is clear. Okay, now we'll move to the next part, where where if you are at this point, if you are at x, what will you do? You'll search for x minus 1, you'll search for x plus 1 in y equal to 0. Okay, we'll write the same thing again. For x in ones, if my x plus 1 is in hash map 1, and at the same time, not or, it should be and, if my x minus 1 in hash map 1, then I can simply do answer plus equal to 1, considering that I have a new right angle triangle. For that reason, I'll simply search for x plus 1 and x minus 1. And we should also handle the inverted right angle triangle. For that, what will I do? This time I'll iterate on zeros array. For x in zeros, what will I do? If my x plus 1, I'll just copy this and update. If my x plus 1 in hash map 2 and x minus 1 in hash map 2, answer plus plus. Perfect. And then I'll just print the answer. That's it. Yeah, I guess everything looks fine. Yeah, we can submit. Yeah, accepted. Okay, so moving to the fifth question. Klee has an array A of length n containing the integers k plus 1, k plus 2, so on plus k plus n minus 1. Klee wants to choose an index I such that a value x equal to a1 plus a2 plus so on plus ai minus ai plus 1 minus ai plus 2 so on till minus an is minimized. Okay, we have to generally consider the absolute value of that x and we have to minimize that. Okay, we'll consider the sample I hope. Yeah, this is the best one. 7 2. We'll consider this example. Hmm. Now this 7 represents n and 2 represents k. Okay, 7 and 2. So what does it mean? He initially mentioned that k, k plus 1, so on till k plus n minus 1 is the array. In that case, n is 7. That means 7 empty slots 1, 2, 3, 4, 5, 6, 7. And the first term in it is 2. The next term will be definitely 3, 4, 5, 6, 7, 8. Okay, so this is our array. Obviously, is a it is a AP progression. It is in the AP series. Okay. Now, or you can even say that it is the first in natural numbers except the first k minus 1 elements. Anyway, better to consider it as a AP series. Now, now, what's the next step? We should find a value x and with an index I such that the value of this a1 plus a2 plus so on till ai minus ai plus 1 so on till that is minimized. Okay, we'll just consider some I equal to 1. If I is 1, what's the value? This is the left part and this is the right part. So 2 minus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So this is one such value. This value is obviously the absolute value is somewhat a bigger value. Compare it to the next value consideration for I, where I have placed my I here. In that case, this is a value which is on the left part and this is on the right part. And this is also some value, but a value better than this. A value better than this, for sure. The same way, whatever the value that we get here, we should try to minimize it as much as we can. Okay, understood? So, what's a I'll what's a logic for this? What's a brute force logic for this? I'm writing a pseudocode. You'll read the array. I mean, you'll construct the array, not reading. After reading n comma k, you'll construct the array. You'll construct the array. After that, what will you do? Right after that, you'll consider all the probabilities. Okay. You'll just say some answer is int max. Int max. After that, you'll place I value for int I equal to 1, I less than or equal to n, I plus plus. You'll consider the sum. Left part sum is the sum of the array from initial part of the array to I, and right part of the array sum is sum of the array elements from ith index to end of the array. From ith index to end of the array, let's just say n. Okay. Now you'll just update the answer with minimum of answer comma absolute of left part, left sum and right sum. That's it. That's it with the solution, and then you'll print the answer at the end. I wrote the pseudocode, okay? That's what I was referring to. If this is 2, 3, 4, 5, 6, 7, 8, what we'll do is the left part sum is 2 and right part sum is this for I equal to 1. And for I equal to 2, this is the left part sum and this is the right part sum. You'll consider the absolute value again. Again, when I is 3, this is the left part sum and this is the right part sum. Also, for I equal to 4, right part, left part sum, right part sum, you'll consider the absolute and update the minimum. This. Okay, understood this part. Now the thing is, we'll observe the complexity. We'll observe the time complexity. T is 10 power 4 and n comma k is 10 power 9. Okay. T is 10 power 4 and n comma k is 10 power 9. If you are given n equal to 10 power 9, is it even possible to initialize an array? Is it possible to construct an array of size 10 power 9? Obviously no, you can't construct. That is point number 1. Okay, we'll try to fix this part. We'll try to get the array sums without even initializing the array, without even constructing the array. That is one challenge. We'll try to resolve that for now. Okay, without even constructing the array, how can we get? As this is in the AP, as it is in the AP, if at all, if my I is over here, if my I is at index 4, how can you get the array sum which is 2 plus 3 plus 4 plus 5 without even constructing the array? How many terms do we have here? Simply can I say I number of terms we are having here? Simply I number of terms. For sure, I terms where I is 4. We are having I terms and the first value is k, which is given in the question. And this is in the AP. Now, can you get the AP sum for this using a mathematical induction formula? Yes. Sum of first n terms in an AP is n by 2 into 2a plus n minus 1 into d, where d is the common difference. Common difference is just 1. As mentioned in the question, common difference is 1. K plus 1, k plus 2, k plus 3, k plus 4, so on till k plus n minus 1. The common difference is just 1. So we can just neglect this, and after multiplying this, we can just add it as by 2. Understood this part? The same way, this is the term I plus 1. This is term I plus 1. How do you get the sum from here to here? This part, you can get it this way. What about this? What about this part? Again, how many elements do you have here? How many elements? Simply 3 elements. How can you get that? How can you get that? The number of elements are n. And out of this, you have to neglect all this. So how many do you have here? Can I simply say n minus I you are having here? And for these n minus I terms, and how do you get the value here? The value here is simply k plus how many terms I? What is k plus I? K is 2. K plus I is 1, 2, 3, 4. And you want the term at I plus 1. Can I say that simply it is k plus I? Yes. First term is k plus I and the number of terms you have is n minus I. What you can again do? A simple AP. You can make use of the same formula that we are using here, right? So this part now can be done in O of 1. O of 1. Okay, issue 1 is resolved. But again, we are now overcoming the challenge MLE. MLE is now completely resolved. We are not at all using any extra space. Here comes the another factor where I equal to 1, I less than or equal to n, and where n can be 10 power 9. You cannot make 10 power 9 iterations. How do you overcome this now? How do you overcome this? How do you overcome this? See, if you look at the problem statement says that you have some value a1 plus a2 plus so on plus ai minus ai plus 1 minus so on till an. Okay, you have some value x and you should minimize it as much as you can. Okay, what do you relate it with? Every time you hear the term minimize the maximum or maximize the minimum, you should just stick to the fact that you must implement binary search over there. We'll discuss why we can implement binary search over there, but this is one factor which we can which you can uh, get to the fact that or realize that you can use binary searches if you're using minimize the maximum or maximize the minimum. Just remember binary search. Okay, now we'll see why binary search. Now we'll see why binary search. Okay, now the thing here is this is left part sum and this is right part sum. Okay, now what is the case? S1 is definitely lesser than S2. Okay, now here S1 is again lesser than S2, but we can say that the value that we got here, the value that we got here, and the value that we got here, which is better? The value that we got here is better. The absolute value is better for second one, for I equal to 1, for I equal to 2. Considering I equal to 2 will give us a better answer than I equal to 1. That is for sure. Again, we'll come here. 2, 3, 4, 5, 6, 7, 8. Left part sum, right part sum. And again, here you observe that S1 is less than S2 for sure. And this is even better than I equal to 2. Again, this I equal to 4, S1 is less than S2. Again, this is even more better than I equal to 3. Now, after some certain threshold, this left part sum will now turn out to be a value which is greater than S2. Now, this is greater than this for I equal to 5. S1 is now greater than S2. From here on, whatever I values that we keep on increasing, S1 will definitely be greater than S2. So from here, for all these cases, S1 is less than S2. True, 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 true. For some value of I. Once you reach a threshold value of I, you'll keep on getting falses. And you have to find that true where you got the last value of I as true. And you should simply return this I. That's it. Okay, I hope you understood the logic. I wrote the pseudocode for the brute force one, and I want you to implement both of these implementations. One is AP and one is binary search. So now TLE is also resolved. Okay, I hope you understood the logic. If yes, start writing the code, submit it, and then again come back to the video. Okay, that's it. We'll discuss the code. Okay, we'll write the code. First, we'll read the input for underscore in range of int of input. We'll read the integers n comma k using a map function n comma input dot split. And now for the code implementation, we are not constructing an array, and in the same way we are not even implementing the linear search code where we are iterating the I from 1 to n. We're not doing that. We're implementing both AP progression part and also the binary search part. Okay, so first, what's the first term? First term is k, so I'll just say first term is k. And what's the least possible answer that we can get? Is simply the first. It is because when n is 1, simply the answer will be first. And similarly for last, what's the last term? Last term is n minus k plus 1. Okay, sorry, is it n minus k plus 1? No, n plus k minus 1. That's what we discussed, right? And now, and we'll just initialize high to last, and now some answer will initialize it to some random one left shift 63. Okay, this control doesn't work in Codeforces. Okay, one left shift 63. Now, while low less than or equal to high, what do we do now? What do we do? We'll calculate the mid. Mid is low plus high by 2. Now we'll calculate the sum for the left part. Left part, we'll say left is, and we'll call a function helper which will help us calculate the sum from first index of the element, which is nothing first term in the AP to mid, to the term mid. And what will be the right part, son? What will be the right part? It will be the first term in it will be mid plus 1, and again what will be the last term? Simply last, which is last. And now we have the left part sum, we have the right part sum. We'll just update the answer equal to minimum of answer comma absolute of left minus right. Okay, now we have the absolute sum and we have updated the answer, and now we have to search accordingly. If left is less than right, if s1 is less than n2, if the left sum is lesser than s2, then we have to update our low with mid plus 1. Okay, we have to update our I somewhere on the right side. For that reason, we are simply updating our low to mid plus 1. Else, update your high to mid minus 1. That's it. And now at the end, just print the answer. Now, what are we left with? We are left with the helper function. Define helper of what all parameters we are passing? 8 and the last term which is let's say till this index. Okay. Now, what are the number of terms we are having? Till there minus the first term plus 1. These many terms we are having in the AP, and what is the sum of AP? N by 2 into 2a plus n minus 1. A plus 1 plus n minus 1 into d. Anyhow, d is 1 here, so it will remain as it is. So better we'll use this outside by 2 and we'll return this value. And we'll now return this value. That's it. That's it with the code. Yeah, everything looks fine. Hmm. Yeah, this one, n plus k minus 1. Okay. Anything else? Yeah, it's fine. We can submit. Yeah, that's it. Okay, guys, we'll start off with the next question. I'll directly explain the problem statement. Okay, first, Firefly is given an array A of length n. Let's here denote the ith cyclic shift of A. I'll explain what is this. Okay, if I consider if I consider this as my array, let's say 6, 5, 10, 13, 3 as my array. If this is my array, okay, if this is my array, the value of A1 is 5, 10, 13, 3, and 6. The value of A2 would be 10, 13, 3, 6, 5. The value of A3 would be, um, what's the value of A3? 13, 3, 6, 5, 10, and this way. This way. Okay. What's the next point? Then, um, array B is constructed in such a way that B is the concatenation of all such arrays. Okay. Now, as far as the thing that we discussed, you understood what is A1, A2, A3, and so on, right? Now, the question is, you have A1 concatenated with A2, concatenated with A3, so on, concatenated with AN. Now, can you guess what can be the size of array B? Array B size is simply n square. If my size of array A is n, the size of B will definitely be n square. Okay. Now, the problem statement is very simple. He'll give you q number of queries. For each query, what you're supposed to do is, you'll be given two indices, x and y. You need to get the subarray sum of B from index x to index y. That's it. The problem statement is very simple. We'll figure out the implementation. But as of now, the problem statement is straightforward, very simple. Okay, understood till here? Now, the next step. How do you proceed? How do you get a solution? First, we'll discuss about the brute force solution. Brute force solution. Okay, brute force solution is to construct what you construct. You'll construct array B, which is of size n square. Okay. Now, what's the next step? What's the next step? You'll read queries for each query. For each query, for each query, what do you do? You'll read some x and y, and you'll loop from x to y, and what do you say? You'll initialize some answer. Now this will come under read, okay, and you'll consider some int answer, and then answer plus equal to some b of I, something like this. Understood the brute force, everyone? Now, what's the time and space complexity? This constructing this will take n square time, and now constructing this will take n square time and n square space, and after that, uh, outer loop q into inner loop read x comma y into answer. Now you're again looping from x to y. At max, the value of x can be 0 and the value of y can be n square. In that case, q into n square is the complexity for this part. Okay. Now the overall time and space complexity would be q into n square plus n square comma n square. Is this point clear? Now we'll have a look at we'll just have a look at these constraints, and obviously into t. How can we forget that? Yeah. Into t. T into this, comma, n square. So overall, t is n power 4 and n is 10 power 5. If n is 10 power 5, n square will be 10 power 10. Okay, now you understand how worse the brute force solution is getting. T into q into n square is our brute force. Q into n square itself is 10 power 15. 10 power 15 into 10 power 4, 10 power 19, which is a complete brute force solution. And again, first of all, this is not even feasible to implement. This is a solution which is not even feasible to implement. What's the reason? Even space is also a challenge for us. Why? Because n is 10 power 5. We are initializing a B array which is of size 10 power 5 into 10 power 5, which will take 10 power 10 space just to initialize an array B, which is not feasible. So we should do something else where we completely prevent using the array B at all. We completely prevent that. How can we do that? How can we do that? Okay, first we'll observe few things from the brute force solution. Okay, we'll observe few things. Let's say this is hmm, this is some A1, this is some A2, this is some A3, this is some A4, this is some A5, so on till this is A1, A1, A2, A3, A4, A5, and so on till the last array which is AN. Now it is clear that every portion of B, which is A1, A2, A3, A4, A5, so on, An, all these portions have the same array length n. Okay, is that point clear? Okay, now moving forward, now let's just look into the queries. Let's just look into the queries. Let's say you got the query, let's say left pointer, let's say this is the left and this is the right. Somewhere over here you have the query. Okay, let's say somewhere over here we have the query. Now, is it really necessary to iterate from here to here? Is it really necessary? No, it is not necessary because we can skip this, we can skip this, we can skip this. What's the reason? A2 will have the same elements which we have in A3, and A3 will have all the elements which we have in A4, but not for A1 and A5. Okay, we have the common elements for A2, A3, A4, which ultimately we have the same elements in the given input array A. Now the breakdown is something like this. If we can somehow find the array sum for this, let's say the array sum for this is K. Now can I say that the array sum is K for this as well, K for this as well, K for this as well. Okay. Now the point is if you can somehow find on which array it is pointing to, and again in on which array it is pointing to, how many times you have to multiply your k with, will keep this part will keep this part aside. We have to find the sum for this part, sum for this part. We'll keep this aside. We'll only focus on calculating the sum for this part. Okay. Now, if I can somehow say that it is pointing to the fifth array, if I can somehow find that it is pointing to the first array, okay, this is pointing to fifth, this is pointing to first. Now, what is the sum for this part? Sum for this part will be simply r minus l minus 1. Do you agree? If they are not pointing to the same, if left is not pointing to the same, Then what can I say? Right minus left plus sorry, minus 1 into k will be the answer for this part. Am I clear so far? Okay. Now, very simply, what's the remaining part? We have to find the sum from here to here, sum from here to here. How can you get that? Using a simple prefix sum. If you can somehow find the index for this, which is as mentioned in the um, queries, what is the sum from here to here, here to here? The sum from here to here is also same as the entire sum minus this prefix part. Okay, do you understand? What I'm doing is I'll consider the entire array sum. Within this, I'll subtract this part. Within this, I'll subtract this part, which will give the sum that I want, which I can get it from the prefix sum. Okay, this part is done. Now, what about this? What about this part? How can I get the sum from here to here? How can I get that? If this is the prefix sum that I am maintaining, simply the prefix sum till here is what I require. That's it, right? This is the sum that I require, and I'll return the same. Simple. Okay. Now, what I want you to do is just understand this logic and try to code it up on your own. If you're not able to code it up, if you're not able to convert this logic, if you're not able to put this logic in a code perspective, then it's completely fine. Again, come back to the video and resume and watch it and watch the implementation. Okay. Okay, we'll start with the code. First, we'll take the input. First, range of input. Now I'll just read an integer n comma m int comma input dot split. Now I'll just read an array list of map of int comma input dot split. Now we'll find the array sum and we'll store it in the variable k. Okay. Now it is clear that n representing the size of array and m representing the number of queries that you will be having. Okay. Now we'll loop over the number of queries. So we'll what we'll do is we'll read the queries and we'll store it in the some queries array. Okay. So you'll consider some query and you'll read the queries in map of int comma input dot split. You'll do this for you'll do this for m number of queries. For for some kk in range of m, you'll read the queries and you'll store it in the queries array. Okay. Next, the simple way to the simple way to what do we say? Construct A1, A2, A3, A4, so until AN is, we'll just concatenate the current array with the same array. Okay. How I'm going to do is, if I'm having this 6, 5, 10, 13, 3, if I want A1, instead of A1, I'll just concatenate and just observe what I'm doing here. 6, 5, 10, 13, 3. Okay. Now if I want A1, can I simply say starting from here, starting from index 1, I'm going to extend, I'm going to consider the next 10 elements. Is this my A1? Simply, yes, true. Next, what is my A2? This is A1. What is my A2? Starting from 10, I'll extend for next n elements. And this will become my A2. And next, this will become my A3. And this will become my A4. And this will become my A5. That's it. I guess this point is clear for everyone. We'll try to implement the same thing here as well. So I'm going to consider some array 2 which stores B, and I'm going to concatenate array with array. Okay, this part is done. Now what I'm going to do, I'm simply going to construct a prefix sum array. So prefix, okay. Now I'll just initialize it with zeros for in range of 2 into n plus 1. Okay. Now I'll have to fill the prefix array for in range of 2n. What should I do? Prefix of I plus 1. I'm considering one based indexing basically. Prefix of I plus my array 2 of I. Okay. Now I'm done with the prefix array. Now I have to consider the queries for x comma y in query, or for L comma R for left and right, or for x comma y in query. What am I going to do? I'll assume that answer is 0 initially. And after this, I should know on which array am I pointing to. See here, if I consider this, I should somehow know that my left pointer or my x is pointing to some array and my right is pointing to some other array. How can I do that? Simply, I can write x, let's say some xx is equal to x minus 1 by n. This will be helping us pointing on which array my L is located is being pointed to. Now similarly, this same as y minus 1 by n. So this will help us on which array am I pointing to. Is it A1 or A2 or A3 or so on till AN. Now keeping track of this is not enough. We should also keep track on which particular index on particular array should also be tracked. For that, simply x minus 1 mod, and this is just a math that we are using. See, on which array are we pointing is also necessary, and also if it is A1, from A1 where are we pointing to is also necessary. Okay, for that we are writing x minus 1 mod m. Similarly, for y, we should also keep track, and this is y minus 1 mod n. Okay, we have all the pointers. Now, what did we discuss later? If this is the case, if this is the case, if this is the case, if my xx is not equal to yy, then it means that we are not pointing to the same array. In that case, simply answer will be prefix of, or you can write it in a alternating way. Okay, so first we'll do it this way. If my yy minus xx is greater than or equal to 2, then what does it mean? My left and right pointers are pointing to two different arrays. Okay, are pointing to two different arrays. In that case, my answer will be yy minus xx minus 1 into k. This is what we discussed, r minus l minus 1 into k. Now we have to care about for the remaining part. We have to calculate the answer for this part and also for this part. We'll do that if my x-axis is not equal to y. If they are not pointing to the same index, then what we should do? Answer plus equal to prefix of xx plus n. This is basically the indexing part. And now prefix of xx plus xr. That's it. And also for the right part, plus equal to prefix of yy plus yr plus 1. And what do we subtract? We'll subtract the remaining. Okay, so with this, if this is not the case, if they are equal, then what you should do? If they are not equal, you'll consider xx plus n minus this part. All these are just indexing. Remember, we're just doing the indexing part. It's because we have concatenated, right? We have concatenated it with the same. We have concatenated the array with the same. Okay, for the same reason we did this. Now if if our L is pointing to the same R after doing the mod and division operator, what do you do? Simply answer plus equal to, what do you do? Prefix of left part plus right plus 1. You'll consider from here to there and you'll subtract this part. Okay, that's it. And at the end you'll print the answer. Okay. Yeah, I guess that's what we have written. Mod n, so this should work. We'll submit. Okay, it gave us the wrong answer. We'll just have a look at the code. Okay, what are we doing here? We're just concatenating, and after that I plus 1. Okay, prefix array construction is fine for every query. Okay, we are printing it outside. We have to print this inside, right? Answer variable should be printed inside. Okay, this should be inside. Okay, for every query we have to print the answers. Okay, we'll submit, and yeah, it worked. Okay, so the core logic is breaking down the solution. First break down um, the array portion by portion, and then simulate, and then combining all the logics is the most important thing here. Okay, so that's it for the video, guys. I hope you like the videos. I hope you like the questions, the explanations, everything so far that we discussed. If you feel the questions that we discussed are interesting, and if you feel the problems are challenging, you can also share your friends to watch the video, work on the solutions and all. So subscribe to the YouTube channel too. As you people know that we also upload the editorial solutions for every contest, lead code, code chef, code forces, all contests. All you can do is just like, share, and subscribe to our YouTube channel. Share it to your friends. And to master more and more DSA concepts other than these contest problems, we we do have a 3 months course that we offer for the students, which is a online batch for weekends. I'll provide the details of that in the video description. You can refer that. Thanks, guys. Have a great day. Bye.